In Ghana, one cottage industry that receives little publicity because it is not food or survival related is beads making. The industry, however, has the potential of increasing the volume of the country's non-traditional exports. Beads are probably the first durable ornaments possessed by human beings, and the appeal lies in uses, diversity, and the myriad of colors, shapes, designs, and materials from which they can be made. Beads are believed to have originated from India, Egypt, and Arabia. In Ghana, beads are part of culture. Among the Ga Adangbe people, they have been used for centuries and still are for female rites of passage ceremonies known as dipo. Girls are literally smoothed from head to toe in beads. They are worn around the arms, legs, necks, and especially the hips to symbolize coming of age. Beads are also used to monitor the growth of a baby. When a baby is born, strings of beads are tied around its waist, upper curls, and arms so that the mother can assess the health of the baby. Christians, Muslims, Hindus, and Buddhists use prayer beads. In recent past, Aid to Artisans Ghana (ATAG), the Center for the Development of People SEDEP and Gratis Foundation have been assisting beads producers in the areas of production methods, marketing, innovation, and technologies.
ATAG has been working with the bead producers ever since it was incorporated in Ghana, basically because we know that beads has been produced at the very grassroots level, and we also did believe that it could be a source of employment for them. ATAG has been working with the bead producers in terms of product development and adaptation. We also do some business training with them. We also look at the production process and the technology used. If I'll start with the product development and product design, you realize that traditionally beads were used more for jewelry and for on yourself, like beads for the waist and that kind of thing. But then we realized that there was a limit to how much they could sell to have effective employment out of just the beads. And that was really for the local market and for the export market in terms of jewelry. So we got some people to work with them, and then we came out with beads used as buttons. We also moved into using beads as accessories. So we got them to work with the other artisans like those in ceramics. So they were using the beads to decorate it, and so then they were producing beads as accessories. We also then got them to combine beads with metal, and that is what is really the aim thing now, using the beads as accessories for metal candle holders. They have the bead and metal candle holders. We also thought that that was not using that much of beads, so we've recently even looked at making chandeliers, which has had quite a good response.
The College of Integrated Rural Arts of the Kwame Nkrumah University of Science and Technology now offers a degree program that should equip graduates to enter the industry and additionally assist community beads producers in improving the quality of their products. That beads can be produced from a wide variety of materials such as leather, clay, metal, stones, bones, bamboo, seeds, to name a few, is evident when one pays a visit to the exhibition room of the college at Kumasi.
In this department, we don't specifically align ourselves to making beads from a particular material. No. We make use of all the various areas, like the textiles, the metals, the woodwork, and the clay, and then the rattan, of course, the bamboo, and virtually everything we can lay hands on. This aspect falls under the metal section or metal working area, since the end product of the beads is to string it into jewelry.
This video is on the production of beads using plastics and glass. The two materials have been chosen by the Center for School and Community Science and Technology Studies, SACOST, of the University College of Education of Winneba and Gratis Foundation to teach the science involved in producing beads using materials, one of which doesn't degrade easily, the other non-degradable, but both enables recycling.
SACOST is a Pan-African Research and Materials Development Center for the promotion of community science and school science integration. It was set up by the African Forum for Children's Literacy in Science and Technology with the support of the Norwegian International Development Agency. And they chose Winneba to be the center. The vision of the center is to promote interdisciplinary research and development of materials related to science and technology in community and its link with school science and technology. Now, the mission of the center is to be a center of excellence, to cultivate or foster endogenous development of science and technology in Africa and in Ghana also, in the area of linking school science and technology to community science and technology.
The environmental effect of producing beads by recycling plastics and glass are looked at. Occupational health and safety of producers are brought to the fore, while innovations and technologies that can improve productivity and quality and at the same time reduce drudgery are discussed. The innovations and technologies are thrown as challenges to students, individuals, and research and development institutions and organizations.
The science in plastic and glass beads making. First, plastic beads. The term plastic refers to organic polymeric materials, that is, those consisting of giant molecules that are formed into desired shapes through molding, casting, or spinning. Examples are polyethylene and perspex, that is, polymethyl 2-propenoate. Plastics which become soft and melt on heating and as a result can be molded and remolded are known as thermosoftening plastics or simply thermoplastics. Thermoplastics are generally linear polymers. Their ability to soften easily is due to the presence of relatively weak bonds between chains. Plastics consisting of three-dimensional network cannot be remolded. They are called thermocertain resins or thermocertain plastics. They are hard and infusible with high molecular weight. This is due to cross-linking or networking between molecules. Let's now look at glass beads. Glass is often referred to as supercooled liquid. It is amorphous and usually transparent or translucent. It is made of a mixture of silicates and cooled from a liquid to a rigid state without crystallization. It can be reconverted to liquid without crystallization by the application of heat. It is brittle at low temperatures and breaks with a shell-like pattern. The largest percentage of glass is soda lime glass. This is alkaline silicate glass made insoluble by adding a small amount of calcium oxide. Soda lime glass is used to manufacture bottles, drinking glasses, etc. Soda glass consists of a mixture of calcium silicate, which is CaSiO2, and sodium silicate, which is Na2SiO2, formed when alkali metal carbonates are fused with silica at 1,300 degrees Celsius. Carbon dioxide is driven off and a complex mixture of alkaline silicate is obtained. The physical properties of glasses vary according to their composition. Glass melts at temperatures as low as 500 degrees and as high as 1,650 degrees.
It is this last property and the relatively low temperature which enables the Asasiaban Women's Group of Kumasi Moshi Zongo to produce beautiful beads, which were originally mostly bought by Muslims for use in praying, but are now patronized by both the old and the young.
Eto nti echirenu na edwano enkwa papa nti ya na ye ne emma na wo moye empintoa de no ye ne wo mo na wo French like ho ne ye nso ye dane ye de no entoma nti ye tasba na kakra ne asan ye ntoma no soso kakra na ye de akogu table so e wo ho no mo ne atwe nti echire na ye dane ne ntoma na ye ene ye nya mma bi omo si ye gidifo omo firi kanya ase ha na omo so kra ba betu efiri ho ene nne nyina kra me kasa omo betu ediru kwasi ala na omo betu na omo so di akogu table so na cheso omo ato tifiri si ye ne ntoma ne de ye nya tufuo e ma omo betu di ko amanane bibiri e ma ye.
Experience has taught the women who have been assisted with the structure to work under by the Center for the Development of People SEDEP to select the right plastic articles from rubbish dumps. These include household items and fittings, parts from refrigerators, radios and television cabinets, pomade and cosmetic containers. Since the market for plastic beads is growing, middlemen have taken over the supply of discarded plastic articles, which are often washed before they are sold to the beads makers. Recycling plastic this way has a beneficial effect on the environment.
Relationship with Asasiaban, that is the women's group at Moshi Zongo, started as a result of one of the SEDEP Women Forum members who had a working relationship with them, inviting them for a SEDEP Women Forum meeting. We meet the first Tuesday of every month. They came for the meeting, registered and became members of SEDEP Women Forum. They were already manufacturing the beads. They had a market. They were working in their homes, but they had a market. People were already using their beads. What we did was to link them up with financing and to also assist them to make beads that will enable them have a wider market, to reach a wider market. So fortunately for us, there's this community in the Netherlands, Almere, which already had some kind of agreement with the Kumasi Metropolitan Assembly to support them in waste management, waste disposal. So this was a very good way of also managing waste. If there is a group of people taking waste plastic and changing it into, or converting it to something as beautiful as beads. Unfortunately, I'm not wearing any of the beads, but they have very beautiful beads that they make. And Almere was interested in supporting us to construct we usually call it a shed, but it's like a workshop for the women. They were working in their individual homes. They were not really organized. So one, we set out to organize them, bring them into a group so that they can access capital better. And then two, to have the shed for them to work together. And then three, with them, create a wider market.
It is estimated that 28,000 tons of plastic products are produced annually in Ghana, while 10,000 tons are imported. Their rampant disposal, coupled with their inability to degrade easily, makes the management of plastic waste a complex issue. In making plastic beads, the raw material is heated in a frying pan over charcoal fire. Spoons and carved wooden ladles are used to stir the spongy semi-fluid paste until the right texture is obtained for rolling it into beads. A strand of plastic, similar to yarn in weaving, is made from the paste and attached to the stalk of guinea grass, which is rotated by hand. Liquefied ceramic dyes in various colors are smeared on the strand before it is rolled. When the plastic is solid or rigid on cooling, the beads are removed for stringing. They are often sold on the stalk. The stalk of guinea grass is straight and smooth, and this aids frictionless removal of the beads. Nose mask will check the inhalation of fumes by the beads makers, and the introduction of small LPG-fired stoves to replace charcoal-burning coal pots will be environmentally friendly. The gas stove should be of size that allows the women to work sitting on benches or chairs, something they normally do when cooking, instead of sitting on the floor. It should also be possible to connect the stoves in a circle form so that the cost of gas can be shared. The gas cylinder should be kept at a safe distance and connected to the individual stoves through a multiple gas nipple and valves with industrial gas nozzles. Educating the women on the danger of inhaling plastic fumes, the cost savings and the environmental degradation caused by firewood production will convince them to use the nose mask and LPG stoves. Unlike plastic beads, glass beads making in Ghana dates back to the 16th century. The Krobos of the eastern region claim that their ancestors brought the craft and skill from the original homeland in Israel through Benin to their present-day abode. Unlike metals, whose constituent atoms are arranged in an orderly manner, the constituent molecules of glass are arranged in a random manner, such as exist in liquids. In fact, glass is often termed a supercooled liquid because it changes from the liquid to the solid state without crystallization. Over a long period of time and pressure, glass behaves like a liquid. Ancient Roman glassware have been found slightly flattened. Glass has many advantages. It is easily shaped, a property that is exploited in beads making, rust-proof, cheap to make, and can be recycled. Bead molds are made of plastic clay and straw, or cassava stalk is used to obtain holes. Alternatively, piercing with a pointed mild steel tool can make holes in glass beads. Sieved glass powder or cut glass is put into baked molds, which are then placed in firewood kilns and heated. The stages involved in producing glass beads are crushing and grinding, molding, firing, polishing, and finishing. The raw materials are discarded glassware, broken louver blades, and broken bottles. They are washed to remove contaminants which affect the transparency and color of the end product. Crushing and grinding, a stage in the beads making process that can benefit greatly from mechanization, is the conversion of solid glass into powder. Traditionally, glass articles are broken with stones or hammer, pounded and pulverized using stones. Innovative beads makers have produced boxes in which glass is broken to avoid scattering and to protect the eyes. SIS Engineering Limited of Kumasi and Gratis Foundation have produced a hammer mill and a grinder that reduce the drudgery involved in increased yield. Using the two, the process generates minimal waste, since both broken glass that end up on the floor during crushing and grinding and leftovers from sieving are recycled. The cost of the glass grinder, which is bulkier and difficult to manufacture compared to the hammer mill, can be saved by increasing the speed of the hammer mill and incorporating a fine mesh sieve to obtain powder. The gratis grinder is a prime mover, reduction gearbox, millstone and mill roll arrangement that pulverizes broken glass fed through a hopper. The rolls rotate under the frictional forces created by the rotating millstone, and the fineness of powder obtained is dependent on the force exerted by the rolls on the glass, which can be varied by means of an adjuster. Sieving. Apart from fine particle size, sieving retains contaminants on the mesh. Fine particle size powders fuse quicker than pieces of glass. The first gives an opaque product, while the second gives a transparent product. Making and drying of molds. Molds for beads are made from plastic clay using patterns which have the desired shapes and are smoothed for using knives and carving sticks. They are baked in kilns and dressed with kaolin to prevent sticking and to improve surface finish. Molds are heated slowly to avoid cracking, and adding firewood gradually increases the temperature. Kaolin is a clay with chemical formula. A clay is defined as an aluminium hydrosilicate which hydrolyzes with water. Charging of molds. Before molds are fired, they are charged with glass powder and ceramic powder dyes to give the colors needed. Pieces of straw or cassava leaf stalk which burn in contact with molten glass are inserted in the center of the molds to form holes in the beads. Why is the straw or cassava stalk able to create a hole in the bead? Being a poor conductor of heat, the straw or cassava stalk used as an insert bends slowly and outlasts the melting and solidification of the glass, during which latent heat or fusion is absorbed and evolved. Firing of molds. Kilns used for beads making are miniature bread ovens with 2 openings for feeding firewood, inspection and removal of molds. The kilns are constructed with ant-hill clay because of its refractoriness and reinforced with vehicle half shafts. They are lined with flat metal bars on which the molds are placed. Temperatures attained are between 700 to 800 degrees Celsius, a range beads makers are able to tell by the color and glow of the kiln. There have been attempts to introduce gas-fired kilns in the past, and this must be encouraged to reduce deforestation. If the beads must be pierced, molds are removed from the kiln when the glass is in a semi-molten state. Otherwise, they are left to cool in the kiln. When they are removed from the kiln, molds are again cooled in the open for an hour before the beads are removed. Heat transfer from burning firewood to glass is by convection within the kiln, radiation from firewood to metal bar conduction, from metal bar to mold, and conduction from mold to glass. Polishing. A mixture of sand and water is used in polishing beads. The abrasion caused by rubbing the beads in the sand-water mixture on a hard surface, such as stone, removes roughness to give good finish. Occupational health and safety and environmental considerations. If the hammer mill and glass grinder are used, waste disposal does not pose a serious problem since the yield is close to 100%. Inhalation of glass powder is dangerous and must be guarded against through the use of nose masks. Safety goggles and protective clothing must be worn. The shed under which beads are produced must be kept clean by sweeping and refuse stored in a container for disposal. Work benches, containers and tools, when not in use, must be arranged. The shed must be free of floods and dust and should be secure from the ravages of storms. The local market for beads in Ghana is vibrant, and this is seen in markets such as Koforidua, Agomenya, and Odumase Krobo. On days specifically earmarked for trading in beads, buyers and sellers arrive at dawn to do business. The discerning eye can, on such days, distinguish between imitation or fake beads that find their way to Ghana from neighboring countries. For functional items or beaded artifacts, objects such as sheets of imported glass and plates are sometimes purchased and cut into pieces using a diamond tool. Beaded artifacts, which are metal bead other material combinations, are carving a niche in the export market, and the onus falls on designers, metal fabricators and beads makers to ensure that beaded handicrafts constitute a sizable portion of the country's non-traditional exports. A challenge is also thrown to students, teachers, design and production engineers to adapt existing and introduce new technologies that increase productivity and improve quality.